Initially, we discuss about current, and then we discuss about direct current, alternating current, EMF, potential difference, resistance, vector affecting resistance. All are included in section of or in chapter of electricity, right?
Yes.
Okay. So now we have to continue with new concept that is related to Ohm's law. Basically, I already told you in the SI unit of resistance. This is the SI unit of resistance, and I told you that there is a law which is related to current, voltage, and resistance. So the name of scientist was Ohm, so that's why we use same law that is known as Ohm's law.
Oh,
Today's topic is the Ohm's law, and Ohm's law is not much very difficult. It is a very simple law. Just simply we start with the statement because there is nothing to explain in detail in this law. Yes, the application of this Ohm's law is very much important. Basically, we already discussed that resistance is the ratio between voltage and current, right? And in Ohm's law states that let's suppose if we keep resistance constant, right? Let's suppose
yes.
we are not going to increase it, not we are going to decrease it, right? So in that scenario, voltage is directly proportional to electric current, right? So statement is very much simple. Current is directly proportional. Do you know the meaning of directly proportional?
Not yet.
You know about it?
No, no.
Okay. Basically, directly proportional means if there are two quantities, because normally when we are going to write directly proportional or inversely proportional, so directly proportional means that if you increase the magnitude of one quantity, so the magnitude of second quantity will automatically increase, right?
Yes.
So basically, current is directly proportional to potential difference. So it means that if we increase the value of potential difference, so the value of electric current will automatically increase, right? So this is the
Yes.
meaning of that. Let's suppose if we consider that your mass is increasing, right? Or let's suppose if we consider that we are having a trolley and we are just filling up with different products. So mass of trolley is increasing, so weight will automatically increase, right? So both are directly proportional, right? So this is the
Yes.
concept the same, that current is directly proportional to the potential difference. But there is one condition: as long as the temperature, the physical condition mean those factor which we were discussing in our last class, cross sectional area and length, because we know if we increase decrease the, so resistance will automatically change. So and the physical condition remains constant. Okay.
Physical relation by what?
Yes. Any problem?
Physical condition what?
Physical condition. Okay. Basically, physical condition means, let's suppose if there is a wire, right? And current is normally flowing through that wire. So let's suppose if you try to turn that wire into like a ring wire, or if you want to try to stretch that wire, or if you just cut that wire. So this is the change in the physical condition, right? And in scientific form, we just consider it
Oh,
as the length. Let's suppose if we increase the length, let's suppose if we attach another wire with the same wire, right? So now wire, the
yes.
length of the wire is extended suddenly. So your both values of current and voltage are now not directly proportional, right? Because there is a change in resistance, because now we are having two wires that are connected with each other, right?
Yeah.
And the second thing is the cross sectional area, right? Let's suppose if current is passing
Yes, yes,
through a wire and we place lighter close to it. So what happens? Temperature increases, right? And wires start
yes,
melting
yes,
slowly, right? So during the melting process, wire become very thin, right? So resistance will automatically increase, just like in the summer days or in summer
yes,
season. The wires from one pole to another got a high temperature, so there will be a short circuit time sometime in PMT or in the transformer. So all these type of thing are going to be happen because temperature is high. So in that scenario, voltage is not directly proportional to electric current. Okay, so these are the scenarios.
okay,
So that is a simple Ohm's law, and we already discussed the formula for resistance. So we can easily derive equation from that equation, and the equation was that R is equals to V over I. We already discussed this formula, right? So if we
yes,
just shuffle the equation, so your final formula will be equal to V is equals to IR, and this equation is known as for Ohm's law, right? This is our main
yes,
equation
yes,
for Ohm's law. V is equals to VI, IR. But we already know that R is equals to VI. We just need to multiply I on the left side because it shows you that V is directly proportional to I if R remains constant. And you already know about the symbols. V represents what? The potential difference.
potential difference here, and the R is current.
Yes. And R is resistance, right?
Yes, yes,
Nice. So you already know about all the terms now. So that is very much easy for you to identify by yourself. Okay. Now further, if we move uh, with the Ohm's law. So basically, when we are working with small circuits, right? Let's just like the circuit of a remote control, circuit of small devices, circuit of mobile phone. So we know that now we are not having lengthy wires or very thick wires, right? We are now
yes, yes,
thin chips and thin wires, very thin wire, micro wires. So now what we need to do, because now we also need to flow current through those circuits also, those components also. So what will happen next, right?
yes,
Okay, so basically we were talking about that V is equals to IR. And while
yes,
we are talking about these circuits and we are going to use these components in our circuit, so there is different scenario, right? So in
yes,
that situation, so we need to discuss about different components, not all components. We are going to discuss about only three important components that is included in your syllabus. The first one is related to the filament lamp, that orange bulb, right? We use those lamps before these energy saver. So the second component is that we need to discuss is known as resistors itself, because it is also made up of conductor, right? And number three, diodes. We need to talk about these three components. These three components are included in our syllabus. So we need to know about, because there are two type of materials, right? Two type of material means some materials are ohmic and some materials are non-ohmic.
yes,
Okay. First of all, let me show you between two categories. There is a difference between two categories. Some are ohmic material and some are non-ohmic materials, right? Basically, what are the ohmic materials? Ohmic material are those materials which simply obeys Ohm's law, right? Very simple thing. Let's suppose if we consider a conductor. So conductor is based on Ohm's law, so it is a ohmic material, right? Because conductor is a simple wire, right? If we consider a conductor, that is a wire. So wire can easily pass electric current. So voltage is directly proportional to electric current, right? Because there is no resistance, no resistor is connected over there. So concept is very simple, right? Any confusion?
Yes. I know.
Okay. So ohmic material are those material which simply obeys Ohm's law, and non-ohmic material are those which are not going to obey Ohm's law, right? So basically,
Yes.
if we talk about the ohmic material, so that completely based Ohm's law on Ohm's law, and we use simple equation V is equals to IR for ohmic material. This equation is for the ohmic materials. We are not going to use this equation for variable conductors or like variable resistor. So this is only for ohmic material. Okay.
Okay.
We are not going to use this equation for non-ohmic material. So non-ohmic materials are filament, diodes and resistors. So we need to talk about these things. So first of all, if we start with a filament, so the first component is filament. Okay, so if we talk about filament, so filament, if you know about the those orange bulb that are
Yeah.
also known as the tungsten bulb, right? So if you
Yes.
know about their structure, so basically there are two very thin wires and there is a spiral wire in between, right? And it is covered with a glass like this. Okay,
Yes.
so these are those filament lamp. Basically, the filament name is of this material is a filament. Filament is a type of material. Basically, the melting point of this filament is very much high, and basically the purpose of and the mechanism of this orange bulb like this, when we try to pass electricity through these wires, so it got hot. That's why it become red or in orange color, and that it will start glow because melting point is very much high, so it is not going to break. And when it got fused, so you observe that there that this spring wire or this spiral wire will got break, right? Are you
Yes.
getting
Yes.
concept?
Yes. Yes.
So basically this is variable resistor. Oh sorry, this is non-ohmic material. And why this is non-ohmic material? Because in this situation current is not directly proportional to electric current. And how it is not directly proportional, let's discuss about that thing. So basically you just need to remember one thing, because in definition they ask about that, write about filament, or what is the statement related to filament, or what are the principle for filament. So you just need to write that the current increases.
So if they ask what this filament, we write this on the thing, right?
Yes, mostly they ask about that how resistance is going to be changed in filament, or what will be the, we can say that what will be the change in, or how non-ohmic material like filament is going to be work. They are not going to ask very detailed question. They mostly ask about their graph in MCQs only, right? Or just ask that what is the difference between diode and filament. So you just need to write one point for each thing. So basically the current increases at a proportionality slower rate than the potential difference, right? And what is the meaning of it? I will explain you all the points.
What? voice is lagging.
Okay, so wait a minute. Now is it okay? Is it fine now?
I can hear very low voice.
Okay, so basically we are talking about the filament, and filament in current increases as the proportionality slower rate than the potential difference. It means potential difference will increase in with greater rate as compared to the current. So it means both are not directly proportional, right?
Again.
In this situation, basically the statement explains you that the potential difference increases at greater rate. It means the rate of change of potential difference will be greater than electric current. It means potential difference will increase quickly as compared to the electric current. Electric current will increase slowly as compared to potential difference, right? So this is the
Yes.
scenario. And if we talk about the individual points, so I will also give you the concept of individual points. Let's suppose why it actually happens. So the first thing is the current causes filament in the lamp to heat up. So basically current causes the heat up of the filament lamp. Second thing is as the current got increased, or simple words that as filament gets, so what happen? Its resistance increases, right? Because we already discussed in Ohm's
Yes.
law that temperature increase. This is another scenario.
Hello, your voice is lagging a lot. No.
Their server issue. Okay, so basically, we're talking about the filament. So basically, filament, again, I will repeat that current increases at slower rate, right? It means voltage is moving fast as compared to electric current, right? So this is the sequence of current and potential difference in filament, that current increases slowly, potential differences increases quickly, right? So there is a difference in increasing rate of current and voltage. Okay,
Yes.
so this is the problem. So there is a change in this situation. And the second thing is that resistance will also increase with increase in the temperature, right?
Yes. Yes.
So that's why when you know that when resistance increase, current decrease, because both are inversely proportional. And we already discussed that resistance is the hindrance in the path of flow of charges, and rate of flow of charges is known as electric current. Now try to interlink all the concepts that we studied before, right? So basically resistance, if resistance increasing, so current will decrease. And if current will increase, so it means resistance is decreasing. So both are like inversely, not are same, right?
Yes.
So this is related to filament. Okay. Any confusion?
Mm.
Okay. And if we talk about the graphical representation, so the graphical representation will be like, okay, before the graphical representation, let's talk about one more component, then we will continue with the graphical representation. So basically, if we talk about the resistor, so basically in resistor, if we talk about the change in current and the voltage, so basically the current increases as the potential difference, the current increases as the potential difference as potential difference will increase, right? So resistance will act like ohmic conductor because resistance is just simply made up of wire. You just make round from a simple wire, so that will like a resistance. Because when we are making loop of wire, so that will increase the length of wire, right? Because now
Yes, yes,
charges are going to move round and round, so that will take more time. So that's why your resistance will automatically increase, right?
yes, yes,
So basically resistor will like a directly proportional combination, but filament will like a inversely proportional. So if we talk about their symbols, because now we need to also study about the symbol of different component, because when we are going to draw a circuit diagram, so we also need to know about the symbol. So basically the symbol for the resistor will be a rectangle with two lines like this. So this is the symbol for resistor, right? And for the
yes,
filament, you just need to draw a circle and cross in the between. So that is the symbol for filament, right? So these are the symbols. This is the symbol for filament, and this is the symbol for resistor, right?
yes,
So in this situation, when current increases, potential difference will automatically increase. And if we consider their graphical representation, so their graphical representation will be, so basically we discuss about two things. The first one is resistor and the second one is filament, right? So let's suppose if you want to draw a graph for resistor and a filament, so graphical representation will be like, if we draw x-axis and y-axis. So for resistor, let's suppose on y-axis we consider electric current. This is electric current on y-axis, and for potential difference we consider potential difference on x-axis, right? Because if we increase or decrease potential difference, so then electric current will increase or decrease. And for resistor, we know that both are directly proportional. So what will be the graphical representation? There will be a straight line because quantities are going to be increased with equal ratio, right?
yes, yes.
Resistor. And and if we talk about the second graph, that is related with what? The filament, right? So if we consider for a filament, so in filament we discussed that the rate of increase of voltage is greater than the rate of increase of electric current, right? So it means voltage will increase more quickly as compared to the electric current. So it means that let's suppose if we start making a, so it will be like initially both are moving with same rate, and suddenly they are in shape, because voltage is now increasing, because voltage is on x-axis, and if the rate of increase of voltage is greater, so you know that your graph will move on x-axis towards right hand side, right?
Yes.
Because voltage is on x-axis. And if we are moving in up vertically upward direction, so vertically upward direction shows you the value of electric current, right?
Yes.
Because if graph is moving in upward direction, so it means that current is increasing, and if graph is moving toward right hand side, so that means voltage is increasing. But the situation of the graph like this, that initially both are moving with around almost same rate, but after that voltage is now increasing because graph is moving towards x-axis, but current is not increasing with greater rate as compared to the voltage. So this is the graphical representation, right?
Yes.
So this is for what? This is for
Filament.
uh, the filament. Okay.
Yes.
So it means that in simple words, we can say that resistance will increase in, right? Okay, so this is the simple statement that resistance will increase with increase in potential difference. So basically, if you are going to increase the voltage, so resistance will increase, but current will not increase. Okay, with this greater rate in filament, but in resistor, both are increasing with same rate. Okay, any
Okay.
confusion?
So what did you say before?
Any confusion in these situations? The situation of resistor and situation of filament.
Where can filament work? Can you do?
Okay, so filament is now clear.
No, no, can you just do the filament? Like, explain. Yeah.
Okay, so any confusion in concept of filament?
Yeah, yeah, can you do the filament one? A bit confused.
Filament graph.
Yeah,
Okay,
graph.
okay. So basically, if we divide the graph in the different components, so initial stage, both current is increasing, voltage is increasing, right? If we
Yes,
consider till this point, because both are increasing, it means that current increases with the voltage.
yes,
So if we draw a straight line, so this straight line shows that that voltage increase with the same rate of electric current. Because if you try to plot a graph, let's suppose if we consider a value of voltage, initial value is 2, then 4, then 6. Okay, and same goes over here, 1, 2 and 3, like this. So let's suppose at initial point we are having voltage 2 and electric current 1, so point will be here, and same goes with the other points. And when we combine all the points, so we will get a straight line. Okay, but what is the
yes,
problem in the graph of filament? That voltage increase with greater rate. So it means our graph eventually shift towards right hand side, because voltage is going to be increased towards right hand side because it is on x-axis. So if we are going to move towards right hand side, so that will increase the value of voltage. So initially, at this point, we observe that voltage and current are almost equally increasing at same rate. I will write it over here so that will be easy for you to understand. So this is our first phase, and at this phase, voltage, that is potential difference, right?
yes,
So potential difference and electric current will increase almost at same rate. Clear? Rate means
yes,
the increase in value with respect to time. Okay, individually. And after that, what happens over here? Let's suppose if we consider the second point, this one. Okay, so in this phase, so what is going to be happen over here? So you observe that graph is shifted towards right hand side. Okay, on x
yes, yes.
towards x side. So we can say that now at this point, voltage, or in other words, we can say that increase voltage is greater than what? Is greater than the rate of electric, right?
Yes.
Any confusion? Now is it
No, no,
clear?
no. Yes, yes.
Because we know that I write this point for you because that will clear you a concept in a very short point, that resistance increase with potential difference. And you observe that orange lamp, that if we turn on that lamp after 5 minutes, the temperature of that lamp was much greater, that we are not able to touch that lamp, right? Did you observe that?
Yeah.
And we also write in the Ohm's law that resistance will increase with increase in temperature. So if temperature increases, resistance will increase, right? If resistance will
Yes.
increase, so voltage will increase, right? But current
Okay.
will not increase with the same rate. It will increase, but with very slow rate as compared to the voltage. So that's why we are not going to apply Ohm's law on the filament, because voltage is not directly proportional to electric current, right?
Yes.
Any confusion?
No.
Now is it clear?
Yes.
Okay. Okay. Basically, we discuss about thermistor. We discuss about filament. We discuss
So
about
all of these three they follow the Ohm's law.
no. You observe that in the graph of resistor, the resistor's graph is a straight line, right?
Yes.
And what is the situation? What is the graph for filament? That filament there is a curve, right?
Yes.
So what is the difference between them? If voltage is directly proportional to electric current, so we are going to get a straight line that is directly proportional, right?
Yes.
And if we observed irregular line or a curved line, so that will give you a concept of variable voltage and variable electric current, right?
Yes.
So it means that resistor is a ohmic material, right? And filament is non-ohmic material, right?
Yes.
So this is the difference in these two components, right?
Yes.
Okay. So now we have the third one, which is known as
The other.
diodes, right? There are different types of diodes, but for this specific purpose, we are going to talk about the thermistor, right?
Yes.
Because other components are going to be included in other chapters also. But for this situation, we are going to observe the graph of thermistor. Thermistor is also non-ohmic conductor, right? Only resistor is ohmic and other two are non-ohmic, right?
Yes.
Okay, and what will be the symbol? So symbol of thermistor will be like just a, it will be like a resistor, but there is only a line in like this. Symbol for thermistor, right?
Yes.
And what is full concept of thermistor is? So basically thermistor works like this. The resistance, the resistance decrease, the temperature increase. This definition gives you the opposite concept of filament, right? In filament, resistance increase with increase in temperature, but for thermistor, resistance decrease with increase in temperature, right? So this is
Yes.
opposite.
Yes.
So basically, in this situation, current will increase with greater rate as compared to the potential difference. Now you are getting concept.
Yes. Yes.
So this is completely opposite to filament in simple words. So your graphical representation will be like this, that again we need to draw y-axis and x-axis. So on y-axis we are having a value of electric current, on x-axis we are having a voltage. So your graphical representation will be opposite with the previous graph. It will be like this, right? And in this situation,
Yes.
observe that if we consider this point, or if we consider this point, so we simply observe that rate of increase of electric current, rate of increase of electric will be greater than the potential difference, right?
Yes.
Any confusion?
No.
So two more things for thermistor only, then we will end up with this topic too. The first thing is that at low temperature, thermistor has a high resistance and little current can flow through it. Are you getting the meaning of this statement?
Can you explain?
This one I'm writing. Basically, it means that at low temperature, related with the basic definition, if you want to relate this statement with the basic definition, so definition is resistance decrease as the temperature increase. So it means that at low temperature, thermistor has high resistance and little current will flow through it, right? But at high temperature,
High
so it,
temperature
yes,
resistor will decrease.
so it will be opposite. So at second point, at high temperatures, because in filament at high temperature, low current will flow, right?
Yes.
But in situation at high temperature, the resistance will be resistance the is low and more current flows through it. Any
And
okay, so if we summarize this concept, so first we start with the Ohm's law, right? Law we discussed that if voltage is directly proportional to electric current, so that is Ohm's law. And those material who follows the Ohm's law that current will pass directly proportional with the voltage, so those components are known as ohmic material.
Ohmic.
Yes, and we have to cover three topics in this concept. So only resistor is our ohmic material. This is our only ohmic material in our equation, and other two are the non-ohmic. These two are non
No.
resistance is variable in this situation. So for filament, we discussed that in filament, the rate of increase of current is very much low as compared to voltage, because in filament, it actually operates on the concept of temperature. When temperature increase, resistance will increase, voltage will increase, right? But
Yes.
increase of current will be very low as compared to the voltage, right?
Yes.
So
Yes.
that's why it got hot and resistance will increase. Then we talk about resistor, and we also discuss about their symbol too. So basically in resistor, current increases as the potential difference will increase. So it means both are directly proportional. So basically it follows Ohm's law because both are directly. And in the third concept, we discuss about the filament. And in filament, the voltage will increase with greater rate as compared to electric current, right?
Yes.
And the final thing is thermistor, and thermistor is completely opposite to filament, right? In this situation,
Yes.
current increase with low temperature, sorry, high temperature. High temperature means high electric current, low temperature means low electric current. So basically this is reverse of that filament, right?